Welcome to part 2 of my plastic welding series. In this video I'll be showing just a little bit more prep work and then we'll get right into it. As you can see here, I will change how I hold the soldering iron, and I will use the flat side to dig a sort of trench all along the seam. Doing this increases the area of the weld and where material can be brought in later on to join the pieces together a bit better. I also have more material that I can put in and make sure that everything is really connected to each other. This makes it a bit stronger than just having a small seam everywhere. It also makes bringing in the material for the weld easier. So now that I've cleaned up the edges again, it's time to start welding. What I do here is I just pick up a piece of ABS and I just bit by bit take pieces off of it and melt them into my little trench. The important part of this step is just taking your time and making sure that everything just gets in there real good. The pieces need to join properly, which is why I do this in multiple layers and just slowly, bit by bit, melt plastic with a lot of pressure and a lot of heat into the seam. I fill up the seams until material is slightly sticking out of it, and this ensures that everything in there is properly joined together. Everything that's sticking out has to be removed later, and it will be sanded down using the files and the sandpaper. And if you fix your parts this way, you will have to paint them anyway, so sanding things down is something that's inevitable. So as you can see here, there's a part of the puzzle that I'm missing. And this just happens. If you don't have everything, you need to make sure to fill it up. In this case, it's only a little bit, so I just put my trusty piece of ABS in there and just melt it together and sculpt it until it looks good. But if you have a larger piece missing, you can use the ABS plate and just make a cutout that fits the hole, and then you have to sculpt in the piece until everything fits. It's something you really can't get around if you're missing a piece, but using this method it's definitely possible to fix even larger holes. You just have to make sure that the shape of everything fits together well and that all the pieces are just joined together really well. And now it's time to clean up the welds. I use the files for the rougher parts and use the sandpaper for the finer parts and the parts where I can't really get with the files. And the cleanup is very important because you will see if you have made any mistakes. You can see small holes or parts where the height of the seam is not on top of the other parts. Sometimes you can see just small little arrows where things aren't really joined together well, and it's better to find these immediately instead of when you try to prep for paint. So I need to make sure that there's no mistakes or anything like that in there, and make just a bit of a clean surface here and look out for anything that looks like I need to fix it. Mistakes can just easily be fixed by applying another bit of ABS plastic on top of it, so you can just weld over what you've done. And this is the result. You can see it's joined together rather well. It doesn't look pretty, and it won't look pretty until it's painted over, but you can see where the materials are joined and how both pieces flow into each other nicely. And now, after finishing one side, it's time to repeat everything that I've done on the other side. And it's really important to do both sides properly. This is where the digging out of the trench, as I called it, comes in, and it's super important that you do this properly. So you've basically scooped out until the middle of the piece on both ends. So all of the broken seam will be replaced with new material on both sides. So the entire broken seam is replaced with new material. This gives it more strength and makes it a reliable piece, and it will be just as structural as it was before. Of course, you shouldn't do anything with the part that you wouldn't do with the original part. And with this part finished, I'm moving on to fixing part of the headlamp out of polypropylene that also got damaged. As you can see here, there's a marking on each of the parts where you can see what material it is made out of. I'm doing this at the end of this video because it's not enough footage to make an entire video about it, and it's not that much damage on it. So here you can see me just put the part in where it would normally sit and put the broken part in next to it, so I have a makeshift jig to hold everything in place so I can join the pieces together in the right way. And with polypropylene things are a little bit different than with ABS, especially because this part is not painted and you don't need to worry about the paint at all. Polypropylene has a lower melting point than ABS, so you need to check for the right temperature, and it also behaves different when it melts. Polypropylene gets really soft, almost like liquid, and that on the one hand makes it a bit easier to spread, but on the other hand the problem is that in some areas it also cools down really fast, and when it cools down really fast the material doesn't really join together. So you need to make sure to check everything thoroughly after you've finished, because these parts aren't just cosmetic parts, they're holding up lights or other pieces, and they need to be structurally sound. It's not really that much weight on them, but you need to make sure that they're fit together properly and that the screws hold and that they don't just fall apart. So after I've tacked everything together, I'm removing the parts so I can work on everything better. And it's pretty much the same that I did for all the ABS parts, just with a little bit more care and a little bit more double checking what I'm doing, because the material is a bit more difficult to work with. If you have pieces made out of polycarbonate, it's pretty much the other way around. Polycarbonate is very thick when it melts, and it joins together a little bit better. But of course polycarbonate is usually used for the glass parts and lights and turn signals and everything, so you will have seams in that and it won't be clear. So that's not really a fix that can be applied in real road traffic, because you might get in trouble for not having proper lights and having tears in them. So it's something to look out for. There are other parts made out of polycarbonate that are not lights, and those are just easy fixable. But the parts where just light has to go through is not something that you should plastic weld, and you should replace them. And we're done. So here's a little bit of a view of the part screwed together with everything fixed, and just a little look at all the seams and all the repairs that had to be done to all of these parts. As you can see, I could screw them together and they hold in place and they don't break when I move them with my hand. So all of the repairs are structurally sound, and the part can be installed on the bike again. Well, after it's painted, of course. So I hope that you've enjoyed these videos and maybe you even learned something from them. I included all of this time-lapse footage because I felt that it was good to see the entire process and to show off how much work all of this really is. Thank you for watching, and I hope to see you on another video.